Good morning, children. Today we discuss about real numbers. What exactly real numbers are. So before going to discuss about the real numbers, we just revise the previous knowledge. What is previous knowledge about the number system? So number system which we are learning from class LKG onwards. So in LKG we start counting learning numbers. So counting numbers are known as natural numbers. Natural numbers, set of natural numbers. Set is nothing but collection of same kind. Collection of objects same kind. So set of natural numbers is denoted by n. Collection of all these numbers 1, 2, 3 and so on. Next, for these natural numbers when we add 0 then it becomes whole numbers starting with 0 and endless. So that set is denoted by whole numbers is denoted by W, starts from 0, 1, 2, 3 and so on. Now, for these whole numbers, when you go for predecessor of 0, there is no other number. Then the question arises, what number will be there? There we introduced negative numbers that are, so negative numbers and positive numbers together we call it as integers. So negative numbers are nothing but -3, -2, -1, 0, 1, 2, 3. These are negative numbers and these are positive numbers. So set of negative numbers and positive numbers together we call it as integers. That set of integers is denoted by I. Set of integers is denoted by I. Here we are talking about negative numbers and positive numbers. Now when it comes to the another set of numbers, that is rational numbers. So rational, the word which we already heard about this rational in class 6th, 7th, 8th, ratio, which is meaning, which comes, rational number came from the word ratio. What exactly ratio? Comparison between two quantities of same kind. Comparison between two quantities of same kind. Here comparison, when we write sometimes a comparison in a fraction or in a ratio form. So when we write in the fraction form, again it comes, that is P by Q form, where Q is not equal to 0 and P and Q are integers. P and Q are integers. So here P by Q form, the numbers which can be expressed in the form of P by Q, where Q is not equal to 0, P and Q are integers, that are called rational numbers. So rational numbers, P and Q are integers. So integers means it can be either positive or negative numbers. Collection of rational numbers. So that set is denoted by Q. Q is nothing but the quotient, because we are dividing P divided by Q. The result obtained as a quotient, from that we derived, we are taking the letter, that is Q. Q, set of rational numbers is denoted by Q, that can be written as -1 by 2, -4 by -5, 7 by 8. These are set of rational numbers. Here we need to observe Q should not be equal to 0. If Q becomes 0, there is no meaning. We cannot define the value. We cannot define the value of 8. That's why Q should not become 0. Q never be 0. P and Q can be integers. Integers means it may be positive or negative. Now in class 9th we learned rational numbers in the definition, even decimal expansion also. What is the decimal expansion? Terminating and non-terminating decimal expansion. Terminating means which ends, terminates which ends. So terminating decimal expansion and non-terminating recurring numbers. Non-terminating recurring. So terminating means which ends, which leaves the remainder 0. Non-terminating means remainder never becomes 0. So terminating decimal expansion. Terminating decimal expansion 0.25. It ends over there 0.37, 1.45, like this. Such type of decimal expansion we say as terminating decimal expansion, because that fraction, when you are converting it to decimal, it leaves the remainder 0. Non-terminating recurring. Non-terminating recurring means it never ends, it never gives the remainder 0, and the division never ends, it will be repeating. A group of digits will be repeating. For example, 1.25, the bar is on 5, so 1.25, this means 1.2555. The digit 5 will be repeating in this decimal expansion. Next, 2.47, bar is on 4 and 7, 47. So 1.474747 and so on. So such type of decimal expansion we call it as non-terminating recurring. Recurring meaning is reoccurring. Reoccurring means repeating. Repeating. The digit 5 is repeating here. Two digits 4 and 7 are repeating here. These two, terminating and non-terminating recurring, are also called as rational number. This topic we learned in class 9th. Such type of numbers also can be expressed in the form of P by Q. In the form of P by Q. Now, non-terminating recurring numbers we observe now. Non-terminating non-recurring numbers. Non-recurring means a group of digits will not repeat. Non-terminating non-recurring means group of digits will not be repeating. Non-terminating non-recurring. Non-terminating non-recurring. This, it never ends and group of digits also will not be repeating. So such numbers are called irrational numbers. Irrational numbers means which cannot be expressed in the form of P by Q. So non-terminating non-recurring, 1.450123976087 and so on. Even the value of pi is also an irrational number. Means when you convert into the decimal form, the value will never end. The group of digits also will not be repeating. Such type of numbers are called irrational numbers. Such type of numbers are called irrational numbers. Now, the topic which we are entering into a real topic, that is real numbers. The combination of rational and irrational. Set of rational and irrational numbers together are called real numbers. Today's our topic is real numbers. So real numbers. What exactly real numbers? Now I hope you understood the combination of both rational and irrational. Rational and irrational. Irrational. So in this you have natural numbers, whole numbers, integers, rational P by Q form, and which cannot be expressed in the P by Q form. Everything will come under real numbers. So rational and irrational numbers together we call it as real numbers. So in this topic, real numbers, we are going to find some new topics: lemma, Euclid's division lemma and Euclid's division algorithm. So real numbers is denoted by R. The set of real numbers is denoted by R. In this, both will be there: rational and irrational. Rational and irrational, both will be there in this. Now in this chapter, the new topic is Euclid's division lemma and Euclid's division algorithm. What exactly Euclid's division lemma and what exactly Euclid's division algorithm? So Euclid's division lemma. Lemma is nothing but a proven statement. The statement which is already proved is called lemma. The statement which is already proved is called lemma. So Euclid's division lemma. Lemma. Lemma meaning is what? A proven statement. Proved statement. Proved statement. Now Euclid's division lemma. Euclid's division lemma. So here A and B are two positive integers. A and B are two positive integers. Two positive integers. A and B are two positive integers. A can be expressed. If you divide A with B, then that expression we can write like this: A is equals to BQ plus R, where A is the dividend, B is the quotient, B is the divisor, Q is the quotient, and R is the remainder. So remainder always lies between 0 and the divisor. This is 0 less than or equal to R less than B. Here the remainder is lying between 0 and the divisor. So if Euclid's division lemma says that A and B are two positive integers such that A can be expressed as A is equals to BQ plus R, dividend is equals to divisor into quotient plus remainder. A is the dividend, B is the divisor, Q is the quotient, and R is the remainder. Remainder always lies between 0 and B. Here B is the divisor. Now in this, by using Euclid's division lemma, we can go for further topic, that is Euclid's division algorithm. So before that, Euclid's division algorithm, what exactly algorithm? Algorithm is nothing but a step-by-step procedure which gives a systematic way to solve any problem. Step-by-step procedure to solve any problem in a systematic way. Algorithm. Algorithm means a step-by-step procedure to solve any problem in a systematic way. That is Euclid's division algorithm. So we are using the word algorithm. Euclid's division algorithm. Euclid's division algorithm. Here two positive integer. Let us assume two positive integer. Why do we use? What is this exactly Euclid's division algorithm? In this procedure, step-by-step procedure to solve a problem in a systematic way to get a solution. So Euclid's division algorithm. Here let us assume C and D are two positive integers. C and D are two positive integers. C and D are two positive integers. Two positive integers. In this, by using this C and D positive integers, we find HCF of two numbers. So assume that if C is greater than D, then C is equals to DQ plus R. Suppose in the first step, if the remainder is not 0, we are using this to find HCF. Suppose in the first step, if you are not getting remainder 0, then this divisor will become as a dividend. This D will become as a dividend. If you get in the first step itself as remainder 0, then D is itself HCF. That's what Euclid's division algorithm says. Euclid's division algorithm. This we are using to find HCF of two positive integers. That is C and D are two positive integers. Then if C is greater than D, then C could be expressed. C is equals to DQ plus R, where a remainder lies between 0 and the divisor. Here the divisor is D. So C is equals to DQ plus R. If you, in this step, if you get the remainder as 0, then that divisor itself is the HCF. If not, then you need to continue for further step. Then this D divisor will become as a dividend. This is Euclid's division algorithm. So based on this, I just will explain a question from exercise 6.1. Exercise 6.1. This type of procedure, the finding HCF, even in class 5th, we learned, that is long division, from exercise 6.1. 6.1. Find HCF of 135 and 225 by using Euclid's division algorithm. Exercise 1.1. It's not 6.1. Exercise 1.1. Exercise 1.1. Use Euclid's division algorithm to find HCF of 135 and 225. So 135 and 225. These are, we are going to find HCF. Find HCF of 135 and 225. Exercise 1.1. Exercise 1.1. Find HCF of 135 and 225 by using Euclid's division algorithm. In these two, which is the greater number? So 225 is a greater number. So 225 is greater than 135. 225 is greater than 135. So 225 is the dividend, 135 is the divisor. 225 is equals to, so dividend and divisor, that is 135. How many times we can divide? Normally we can divide even like a long division type, that is 225, 135. One time it goes 135. Now 0, then 1, 12 minus 3, 9, 5 minus 5, 0, 12 minus 3, 9, 90 is there. Now this 90 will become as a divisor. So 135 into 1 plus 90. Now here the remainder we got as 90. We didn't get the remainder as 0. That means the new divisor, this 135 will be the dividend, 135 will be the dividend. Now the new divisor is 90. New divisor is 90. 90, how many times? You have to continue the division like this till you get the remainder 0. 135. This divisor will come over here. 90 ones are 90. So 45. Now 90 into 1 plus 45. 90 into 1 plus 45. Which will give you, here also we didn't get the remainder 0. So now this 90 is the divisor, it will become as a dividend. Now the remainder 45 will become as a divisor. 45 into 2 plus, now here 45 2s are 90, that is remainder 0. Therefore HCF of 135 and 225 is 45. This is how we find HCF by using Euclid's division algorithm. Step by step procedure. Till we get remainder 0, we have to continue the same process.